imaginary numbers, complex numbers, okay? So again, hopefully most of this is review, but hopefully it jogs some memories if you don't remember everything about it. An imaginary unit is I. So I is considered to be an imaginary number, and it's defined as the square root of -1. So technically there is no number that when you multiply it by itself will give you a -1, which is why this imaginary number was created, okay? So when you see I, you know it's a square root of 1, and when you see I squared, you should know that that's -1. So if I squared what was on the outside and the inside, you would end up with a -1. So complex and imaginary numbers, okay? In every complex number, there's a real part and an imaginary part. The real part obviously doesn't have the I, and the imaginary part does have the I. And in standard form, the I comes last. So the number without the I would come first, and the number with the I would come second. So a lot of times it will say simplify or evaluate and write your answer in standard form. Standard form, you're always writing the I last. If there is no A, so like if the A was 0, let's say, then that complex number is called a pure imaginary number because there's no real part to it. Okay, so these are just some examples of complex numbers. So again, the real part is the one without the I. The imaginary part is the part with the I. So if you were looking at this, the -4 plus 6I, the A is -4, and then it is BI. So the B is actually a +6. On this one, 2I, there's no A, so A would be 0 and B would be 2. And then on this one, there's no I, so the A is 3 and the B would be 0. So if you are just identifying A and B, A is what's by itself without the I, and B, is what's in front of the I. So you can say that complex numbers are equal to each other, the equity of complex numbers, only if A equals C and B equals D. So if I had two sets of complex numbers, like 2 plus 3I, it would equal 2 plus 3I because these two are the same and these two are the same. Okay, so if you're solving or setting them equal, that's what that means. All right, so this says express as a multiple of I. So the first thing you want to do, in my opinion, when you see a negative is pull out the I. So when you pull out a negative, and I'll show you like the long process, but hopefully we could shortcut this. Like this is technically the same thing as saying the square root of -1 times 16, right? Everybody agrees on that? Like I could separate that out. And then this would be the same thing as saying the square root of -1, geez Louise, times the square root of 16. Still agree? So we say that the square root of -1 is I, and the square root of 16 would be 4, and then we always write the I last, so this would be 4I. So as soon as you see the negative, you want to pull it out. That's what I do. So this comes out as I, and then the square root of 16 would be 4. But that's the breakdown of it. Okay, that's the explanation of it. And then the bottom is the reverse. Now we're taking something that says 7I and we're squaring it, which means you're squaring the 7 and you're squaring the I. So what's 7 squared?
49.
And what's I squared?
-1.
So this is -49. So an I raised to an even power becomes a +1, okay? An I to the 24th power, hopefully we don't have to work that out. An I to the 24th power would be a +1. Any even power would be a +1. I mean a -1, sorry, a -1. An I raised to an even power is a -1. All right, adding and subtracting complex numbers. So you're going to treat I just as though it was an X, like it's a variable. And then combine like terms. So two terms that have the I on it can be combined. Two terms that don't can be combined. But you can't do like 2 plus 3I and combine that into 1. So two different examples here, A and B. So in A, I've got 7 plus 4I minus 9 minus 5I. And then in B, 8 plus 3I plus 17 minus 7I. So what's the first thing you want to do with A? distribute the negative, and that negative goes to both. So I'd get 7 plus 4i minus 9 plus 5i. And then combine the two real parts, which are 7 and negative 9. I get negative 2. Combine the 4i and the 5i, and I get positive 9i. And then b is just addition, so I don't even have to distribute. Just combine my like terms. So 8 and 20 and 17 becomes 25, and then 3i minus 7i becomes negative 4i. Again, standard form puts the I last. Olivia.
If you had like terms that could be reduced, but you reduce it.
By reduced, you mean like take something out? No. So it's actually more reduced the way that it is than if you took something out. So if it said to like factor it, then you would take something out. But when you're writing it like this, you would leave it.
Okay.
You'll see when that comes into play. Like if I have a fraction and I want to simplify, then I would do it. But when you're just writing the expression, you would leave it. All right, so multiplication. Obviously, if I'm multiplying two binomials, I FOIL just like I normally would with any two binomials, except that I'm going to probably end up with an I squared somewhere, and you need to remember to replace that I squared with a negative 1, and then simplify your expression. So just says perform the indicated operation. Usually it will say, and then put it in standard form. Okay, so I'm going to FOIL this out. I multiply the first, 18. The outer, negative 6i. The inner, negative 30i. And the last, positive 10i squared. So I have 18, negative 6i and negative 30i give me a negative 36i. And then this becomes a negative 1. I squared becomes a negative 1. So I'd get 18 minus 36i minus 10, which becomes 8 minus 36i. Questions on that one? Okay, you do B. All right, so when I expand this, this is 2 minus 3i times 2 minus 3i. So I can't distribute an exponent, okay? Make sure you duplicate it, expand, and then FOIL it. So this would be 4 minus 6i minus 6i plus 9i squared. This is 4 minus 12i. This becomes a negative 1, so I get negative 9. Negative 5 minus 12i. Raise your hand if you got it right. Okay, good. Any questions? All right, conjugate of a complex number. So the conjugate of a complex number, like a plus bi, is a minus bi. So you keep the sign on the a the same, but you change the sign on the b to find the conjugate. So a plus bi conjugate would be a minus bi, and a minus bi conjugate would be a plus bi. So you only change the sign on the b. When you multiply a complex number by its conjugate, you get a real number because you eliminate the I term, and the I squared term gets placed the negative 1. So by multiplying a complex number by its conjugate, we actually make it a real number. So if you look at the bottom there, like this is just if it was actually A and B. If I multiply the first two together, I get A, and then the outer would be negative ABI, inner would be positive ABI, and last would be B squared, I squared. So the I squared becomes the negative 1. Multiply that times the negative, and the middle terms cancel out. Multiply that times the negative, and I end up with a squared plus b squared. So this is a shortcut, actually, okay? If I end up with a, whatever this is, a plus bi and a minus bi, and I want to multiply those together, then the shortcut is a squared plus b squared. So we eliminate the I because the I would make that minus a plus, and we get rid of the middle term. So if I'm multiplying something by its conjugate, and it involves the i's, obviously, then the shortcut would be a squared plus b squared, which is going to help you when you get to rationalizing. All right, so this says write the complex conjugate of the complex number, and then multiply the number by its conjugate. So what would be the conjugate of 7 minus 10i? 7 plus 10i. And then if I multiply those together, I can FOIL it out. 49 plus 70i minus 70i minus 100i squared, or use the shortcut, which is 7 squared plus 10 squared. 49 plus 100, which is 149. So if you forget the shortcut, stick to the basics. Expand it and FOIL it. So B is not written in I format yet, right? How would I write that as a complex number? So this would be I root 5. Okay? So when you write out the I's and the roots, I don't care if you put it, technically the I's is to come last. I don't care if you put it in front of the root or you put it at the end. Just be careful because a lot of people end up doing this and then putting the I underneath. Okay? That is not the same as this. So you can either write it as root 5 with the I on the end, or you can put the I in the front of the root. I don't care which one, okay? But make sure that I is not underneath the root. So if this is my complex number, then my conjugate is negative root 5i. And when I multiply those together, I'd get root 5 times root 5, which is a positive 5, okay? The negative and the I squared would cancel out. Question on either of those. So the end result when you multiply a number by its conjugate should be a real number. When you do this and you go write that number on a line, that number should not have an I on it. All right, so we're baby stepping into this. Complex numbers and fractions. So to eliminate a complex number in the denominator, you're going to rationalize the fraction by multiplying both the top and the bottom of the fraction by the conjugate. So you can't have an I in the denominator because that means that you have a square root of a negative number in the denominator, and we know we can't keep a square root in the denominator, so we have to rationalize it. And you do that by multiplying both the top and the bottom, or numerator and denominator, by the conjugate of the denominator. So as an answer or part of a problem, if I had 2 plus 3i, let's just say, over 5, that's totally fine, okay? Because an I, a square root, can be in the numerator, but I can't reverse that. Like 5 over 2 plus 3i would not be okay. I'd rationalize this by multiplying both the top and the bottom by 2 minus 3i, or the conjugate, okay? So this is okay, this is not. This would have to be rationalized. Divide and express the result in standard form. So what's the conjugate of 5i? Good. Negative 5i. So I write negative 5i there and negative 5i here. I'm multiplying both the numerator and the denominator by it. So my numerator is negative 15i, and my denominator, remember that would be my b squared, which is 25. Or negative 5 times 5, which is negative 5i times I. So this is negative 25i squared, which becomes negative 25 times negative 1, which is where I get the positive 25 from. Now this is a fraction. Can I leave an unsimplified fraction as an answer? Never, right? So what goes in both the top and the bottom there? Good. So this would be 3 and this is 5. So you can either write it as negative 3i over 5, or if you see this on a standardized test, they will separate out that I, and it would be negative 3/5 and then the I at the end. Either one of these answers is fine. Okay, but on a multiple choice test or a standardized test, you're going to see the answer with the I written last after the fraction. Still with me? Everybody's good? Okay. All right, so then B, what would I have to multiply by? 5 plus 9i. So first thing I'm going to do is FOIL out the top. So 7 times 5 is 35. 7 times 9i, positive 63i. 6i times 5, 30i. And 6i times 9i, which is a positive 54i squared. Then combine your like terms from there. So 35 would go by itself so far. 63i and 30i become 93i. And then this I squared becomes a negative 1, making that a negative 54. And then I can combine together 35 and negative 54, which is negative 19 plus 93i. So that whole thing is just your numerator. And then I've got to work out the denominator. So I want to multiply this. Again, you can do your FOIL and simplify it, or you can use the shortcut, which is square the first term. And so the a, and then square the b and put a plus between them. So 25 plus 81. And I'd get 106. And then that goes in the denominator. So the standard form with the fraction, you'll see on standardized tests and stuff, will be separated out. So this is negative 19 over 106 plus 93 over 106, and then the I comes at the end. And then if either of those fractions can be reduced, you need to. All right, so the principal square root of a negative says that for any positive real number b, the principal square root of the negative number negative b is defined by the square root of negative I equals I square root b. We have already done this. We have already said that if there's a negative underneath the square root, we pull it out with the I. That's all this says, okay? But you're going to get these in more than one way, okay? So if you see negatives involved in addition, subtraction, multiplication, all that stuff underneath the root, you must first express the root in terms of I and then simplify. So if I am square rooting negative 25 and I multiply this by the square root of negative 25, and I didn't simplify first, I would get the square root of 25 times 25, right? Because if it's negative 25 times negative 25, what happens to the negative if I multiply them? A negative times negative becomes positive. I would lose that, right? So that's 625 right here. And then I would get back 25. This is wrong. You have to pull the I out before you can perform any function on these roots. So this actually becomes I root 25 times I root 25, which would be I squared times the square root of 625, or negative 25. So be really careful. Do not perform any operation on a negative root until you have taken the I out, okay? All right, example 6 says to perform the indicated operations and write the results in standard form. So like we just did on the last slide, the first thing I have to do is take out the i's on the negatives. So I would have an I square root 54 minus 7I square root 24. And again, you can put these i's after the roots or before them. Just be careful not to put them under them. And then I can't combine them how they are, but I can simplify the square root. This would be 2 and 27, which is 3 and 9, 3 and 3. So I can pull out a 3, put it on the front with the I, and then the 2 and the 3 would get multiplied together because they don't have a pair. And then do the same thing with the 24. This would be 2 and 12, 2 and 6, 2 and 3. And this time I can take out a pair of 2's. That's going to go on the front with the 7. So it's minus 7 times 2, which is 14i. And then the 2 and 3 don't have a pair, so they get multiplied together underneath. So now these both have an I, and they both have a square root 6, which means I can combine them into 1. So I would do 3i minus 14i, or negative 11i, and then square root 6. So you can write it like that, or negative 11 square root 6i. Just make sure that I is not underneath the square root. Okay, example 7 says perform the indicated operations and then write the result in standard form. So notice that the directions are starting to seem the same and you're going to have to approach them however you would normally approach. So in this case, we are multiplying. For A, we're going to expand this and FOIL it out. So I would get this as 4 plus root negative 7i. So this is 4 plus I root 7, 4 plus I root 7. And then FOIL it out. So 16 positive 4i root 7 positive 4i root 7 and I squared and square root 7 times square root 7, which is just 7. So this becomes 16 plus 8i root 7. This becomes a negative 1, so this is a minus 7. And I get 9 plus 8i root 7. So again, it can be written like this, or that I can get bumped to the end as long as it is not underneath the square root. So I will take either of these answers. If it is multiple choice, it would be written as the second. Okay, B. So now I've got a negative under a root in the top. So this becomes negative 8 plus I root 48 over 4. And now I want to simplify that square root of 48. So this is 2 and 24, 2 and 12, 2 and 6, 2 and 3. For every pair of 2's, I take 1 to the outside. So that's 1 that's going to get multiplied by the 2. And then there's another pair of 2's, so another one gets multiplied. The 3 that doesn't have a pair is going to stay underneath the radical. So this becomes negative 8 plus 2 times 2, which is 4i. And then the square root of 3, because the 3 was the only thing left underneath, all over 4. So you can simplify it before you split it, but eventually you're going to want to split this either way. So it's up to you how you simplify it. Because this, so I'll show you both ways. Because all of them are divisible by 4, this would be 1, this would be 1, this would be 2. So I'd get negative 2 plus I root 3. Or negative 2 plus root 3i. So either of those answers work. If you split it first, then I would get negative 8 over 4 plus 4i root 3 over 4. And then the 4 goes into 8 2 times. These 4 cancel, and I still get negative 2 plus I root 3. So either way, you end up with the same answer, whichever one you get is fine. All right, this last example is for the quadratic formula, but when we've talked about the quadratic formula, so now we can have i's or imaginary numbers. So just a quick refresher that the quadratic formula is negative b plus and minus the square root of b squared minus 4ac all over 2a. So from this one, the a would be 4, the b 12, and the c 15. And then just plug it in. So it would be negative b, which is 12. So negative 12 plus and minus the square root of 12 squared minus 4 times a, which is 4, times c, which is 15, all over 2 times a, which is 4. So I get negative 12 plus and minus the square root of 144 minus, this is 60 times 4, 240, all over 8. And then negative 12 plus and minus the square root of negative 96 over 8. So I take out the I making this negative 12 plus and minus I root 96 over 8. And then I want to break that 96 down. So 96 breaks down into 2 and 48, which is 2 and 24, which is 2 and 12, 2 and 6, 2 and 3. And then for each pair of 2's, one of the 2's goes to the outside with the I. So this is 1, this is 2, and then the 2 times 3 doesn't have a match, so it would stay underneath. So I get negative 12 plus and minus 2 times 2, which is 4, I root 6 from the 3 times 2 over 8. Break that apart. 4 root 6. I'm going to put the I at the end and then reduce each fraction. So this would be 2 and 3, 2 and 1. And I get negative 3 over 2 plus and minus root 6 over 2I. So you want to make sure that every part of your square root is, or every part of your fraction is simplified. And then put the I, shift the I all the way till the end. If this was a root that could have been actually square rooted, like square root 50, let's just say, then I would just, or sorry, square root 25, I would just square root it and then keep it again as simplified fractions. That's the end of 2.4.